Hello, this is Russell Hawley coming to you from the Tate Geological Museum at Casper College here in Wyoming. And today I'm going to talk to you about something that's not actually a fossil, but it's crucially important to understand it if you're going to study fossils of creatures like ammonites and orthocones. And that creature is the modern chambered nautilus. And you probably are familiar with this from shells sold at places like Pier 1 Imports. And they are a planispiral shell like this. This, of course, is the only part you see in the store, but of course it was once part of a living animal. And although it looks like a snail at first glance, in life, the head sticking out of the aperture here would have had tentacles growing out of its face. Here's a drawing of the live chambered nautilus. These are cephalopods. They are related to modern squid and octopus. And different species of cephalopods have different numbers of appendages. The octopus has 8 arms. The squid has 8 arms plus 2 long tentacles for a total of 10. But the chambered nautilus has 90. So there's a whole bunch of appendages coming out there. It's got a tube, a hyponome, and it can swim by squirting water out of the hyponome, and then the nautilus scoots along in the opposite direction according to Newton's third law of motion. That's jet propulsion. And then it's got a pair of eyes that work on the pinhole camera principle. There's a very small aperture, and then that focuses the light hitting the retina in the back. Now, one of the most important differences between a nautilus shell and a snail shell, and this is one that shows up in the fossil record as well, is that if you cut a shell of a chambered nautilus in half, you can see how it got its name. The shell is divided up into chambers. The chambers are called camerae, and the partitions, or if you're of a nautical bent, the bulkheads that separate one chamber from another are called septa, and those septa meet the outer edge of the shell in a relatively simple curve called a suture. That'll be important in future episodes. So if we were to take the entire nautilus with the living animal still inside and cut it in half, it would look something like this. Here's a diagram of the nautilus in sagittal section. So here's the soft parts of the animal here, and then here is the chambered part of the shell. Now the shell that I just showed you is in parasagittal section. That is to say that although it's been sliced, it hasn't been sliced exactly down the middle, so we're missing the structures of the very center line of the animal. You can see those in the diagram, however. And this is the really important bit right there. A tube that runs right through the center of each one of those septa and allows the interior of the chambers to communicate with each other. That tube is called the Cifuncle. Can you say Cifuncle? Good, because it's an important word. It'll come up a lot in our discussions in future. At any rate, what the Cifuncle is for is to allow a thin thread of tissue called the hyponeme to communicate with the interior of the camerae and absorb the fluid out of them and leave behind what starts out as a vacuum but eventually becomes a low pressure gas, and that allows the animal to float. They're buoyancy tanks, and they allow it to control its position in the water column, just like a little tiny submarine. Then down here we've got the animal's jaws, and these two bits here represent the brain. The brain's shaped like a donut, and when the nautilus is eating, the food actually passes through the middle of its brain on the way to its stomach. So if you're seeing a nautilus feeding, you might be wondering, what's going through its mind? The answer, food. Then we've got the gills down here, and then here's the mantle cavity and the hyponome coming out there. By the way, there's a folk rock band that plays music by blowing through the shell of the chambered nautilus. Do you know what the name of that band is? Garmin and Cifuncle.